Hey guys, this is Ben Smith. This is my 460 hydraulics case study presentation. I did my presentation on a New Holland C227 tracked skid steer. The actual skid steer that I worked on at the time, which was a couple years ago, was a friend of mine's. They own a cattle farm, and that was pretty much all they were using it for. There was some other stuff they did on the sides with it. But for the most part, it was just around the farm. It was in quite a bit worse shape than the one in the picture, but it was the same components, same machine and whatnot. So the machine itself, like I said, it's a New Holland. It's a tracked skid steer. When we did the work on it, it had just over 2,700 hours on it. Today it has a little bit more than that, but not a whole lot. The actual repair of what went wrong here didn't get resolved for quite a while. They had other skid steers. They weren't in a huge rush to fix it. It is fixed now. It pretty much came down to a cost thing. So just to familiarize us a little bit, it's a pretty common machine, and the attachments you can get for it are pretty common with all other skid steers. I threw a few in here. You can get forks, you could have plows. Obviously you can get thumbs, whatever you want. If you're willing to pay for it, you can pretty much get whatever attachment you would want on one of these. So some of the main components, particularly the ones that we're going to focus on today, with the problem that we had in the machine, are the fixed displacement pump, which is a gear pump. We'll get more into the specifications on that later. Back up top, the reservoir itself, obviously, that's where your fluid is. It's kind of the blood of the system. The main control valve and both of our cylinders. Both the cylinders are thrown in there. It's kind of obvious, but just because that was where we noticed the problem that we had. And then clearly there's a lot of other components to these systems as well, hydrostatic drives, and there's other valves in there, but these are just kind of the main ones that we're focusing on for the problem that we had. So the other big one is the filters and strainers. This machine lays it out pretty nicely for us. There's a screw-on filter, which number one is pointing at. It's really easy to get at from the back of the machine when you get it all opened up. And then the other one is a strainer that's in the fill cap. There's also a hydraulic breather in there. But that strainer and this screw-on filter are the two main things, filtering and conditioning our fluid. So this is the gear pump. Mentioned it earlier. These are just kind of the basic overview specs of it. Operating RPM is 2,600. And at that RPM, this pump will produce 24.8 gallons per minute. I threw in there the actual pump displacement also, which is 2.1 cubic inches. And then the other big one is hydraulic fluids. So some specs on that. If you look right in here, for a C227, our capacity is about 10 gallons. And then all the machines listed here, ours included, uses this Tutela Auto Supreme engine oil, which is a 10W30. It's pretty commonly used in hydraulic systems. It is what was being used in this machine at the time. It had been changed multiple times. There'd been a couple other minor issues, and particularly some cleanliness issues. But we'll get a little bit more into proving that in a minute. So our complaint right off the bat, there was low hydraulic power. And then under that, I have it written that the system was noisy whenever loaded, which is a little bit of an understatement. I watched the machine get run. There was noise going on whenever the pump was running, whenever the hydraulic system itself was running, and it became pretty extreme when there was a load on it, or when it was idled up at all. If you were running at operating temp, there was a pretty nasty whine coming out from under the seat. So those were the basic complaints going on. The noise was the biggest thing that threw us off. Low pressure was something we thought of with low power, but as soon as you could hear the noises that it was making while it was actually running or doing work, it was pretty clear that there was something worse going on. So for our initial thoughts, like I said, right off the bat, we checked fluid levels, make sure we were not low on anything. And then the other big one we thought of was system relief pressure. I don't love the way we went about it at the time. We went in and started adjusting that relief pressure. It didn't make a difference. Like I said, the key thing that we heard and thought about was the noise that was coming from the system, which pointed pretty clearly to something being wrong. That wasn't just related to a low pressure issue if everything was working properly. And then I have it written at the bottom later, the hydraulic fluid sample test. They did take a sample of the fluid, they sent it in. It came back after there was already a complete failure of the system. They ended up with no hydraulic power, and it quickly became pretty clear what the issue was. So into the cause here. When the sample did come back, it was clear why the failure happened. There was an excessive amount of water found in the fluid. Nobody really owned up to knowing how it got in there or what happened, but regardless, it happened. And so basically it caused that fixed displacement pump to fail altogether. So I have a kind of a picture down here. You can see on the right is protected or clean hydraulic fluid, uncontaminated by water. And then on the left, if you can see kind of the little dots in there, and that's supposed to represent contamination found in there. In our case, water found in there. The machine didn't get used on a daily basis. My guess is things separated pretty well, but when they started running, there's a lot of water getting pushed through that system, which can pretty quickly wreak havoc on the components in it, particularly things like control valves, like pumps, and pretty much anything that needs proper lubrication. That would be the biggest thing. So I just wanted to throw this in here kind of to show you we've got some separation of the two. You can tell that neither part of that is safe to be running through your hydraulic system. Same with the first three. They're just kind of three different steps of water contamination, separation or not separation. And then this one would represent clean fluid being put in after the system is drained, cleaned, damaged components are replaced. There's a lot more that can go into it when a component's damaged by this with corrosion. You can get metal particles flaking off and breaking off, and those can also cause catastrophic failures further downstream. In our case, the pump being the issue. If that stuff is sent down into the control valves, into the hydrostats, they can cause thousands and thousands of dollars worth of damage depending on how long the machine is run or not properly cleaned after the failure originates. So their correction, like I said, it took a while. It's back up and running now. That hydraulic pump had to be replaced. They ran a few different flushes through the system. They ended up sending in the control valve to get inspected by professionals. They didn't end up having issues there. There was signs of some damage in other components, but evidently it wasn't anything that was going to keep it from running properly for the present time. New hydraulic fluid had to be put in. They also pulled off other components. They drained lines, had those put back in. They wanted to make sure that everything was cleaned out properly and that there weren't going to be further issues. So that's the end of the presentation. Overall, the biggest issue was hydraulic cleanliness. We went over that a lot in class this year. Kind of the number one thing that you can do on a daily basis is to make sure that your fluids are clean, that you're not getting water in them, that you're not getting dirt in them. keeping up on your routine maintenance, making sure that your filters aren't clogged, because if they are, you can have problems like this that results in multi-hundred or multi-thousand-dollar filter or pump replacement. Thank you.